Alright, Common Core Algebra 2. So we have talked about now in 5.5 about how to find zeros, which remember zeros also mean x-intercepts, and based on that factor theorem, they're also going to tell us a factor. So big thing as a quick reminder here, if something is a zero, so let's say that some number c is a zero, then that tells us, remember, x minus c is a factor. So let's say we have some polynomial like f of c equals whatever, okay? If c is a zero, meaning if I plug in c I get out 0, then x minus c is a factor. Okay, so that's a quick review of the factor theorem, which is a very important one. Remember, we could do synthetic division, or we could even apply the remainder theorem to determine if it is a factor. So the rational theorem today is more an idea of how we can find those values of c, or how we can find some of those values of c. Now, when we use it by itself, it is helpful and definitely limits it down from an infinite amount of number to a very finite amount of numbers. But when we use it in conjunction with our calculators, it becomes infinitely or much more helpful. Okay, so if a polynomial has some leading coefficient, and we're going to call that q, so remember that just means the coefficient of the term with the highest degree, so write it in standard form, that'll be your first coefficient, and a constant term p, so remember constant term means it's that last term, there is no variable associated with it or multiplied times it. Then, if that is the case, so we have some leading coefficient q and some constant term p, all of the rational roots, rational meaning fractional or integers, not irrationals, not imaginaries like we've talked about, are going to be the factors of p divided by the factors of q. And in this case, the biggest thing that we need to remember as well, or one of the important things we need to remember here, is that that includes both the positive and negative factors. So you're going to see this written every time, and really that just means think in terms of positive and negative. And so we're going to create a list of all the factors of p divided by all the factors of q. What that would look like if I come up with this example here. So now we have a polynomial f of x equals 2x cubed plus 6x squared plus 5x minus 6. Then that tells us that p, that constant term we talked about, is this negative 6. Now the nice thing is we don't really care about that sign. Yes, p is negative 6, and it's important that we're able to identify that, but it is not really going to be that important when we start to talk about the factors of negative 6. And then f of x has a q value, or a leading coefficient, of 2. So this we would call a quartic cubic. Well, I'm sorry, not a quartic cubic. We'd call this a 4-term polynomial that is a cubic. Cubic because it has a cube here, and it is 1, 2, 3, 4 terms. So we've identified p is negative 6 and q is 2. Then that means the factors of negative 6. So that means numbers that multiply together. And we don't actually care about them as factor pairs like we did when we were factoring, like 1 and 6, or actually we should say negative 1 and 6, or 1 and negative 6, and 2 and negative 3, and 3 and negative 2. We don't care about that. We just care about all the numbers that actually 6 is actually divisible by, is a better way to think of it. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are all of the numbers that 6 is divisible by, negative 6. And you can, remember, do that in your calculator too if you're having trouble identifying some of them. Now most of them are going to be pretty small numbers for us right now, so we're going to be able to generate that list fairly easily without our calculators. And then q, a nice easy one, that leading coefficient, only has 2 factors, 1 and 2. So plus or minus 1, plus or minus 2. So we've identified p and q, and what we need to do is put all of the p's over all of the q's. So that means I'm going to take each one of these individual q's and divide them by each one of these p's. So when we divide by 1, first one we'd get is like plus or minus, and we're always going to have that plus or minus 1 over 1. Well, that's just 1. So we can just think of that as plus or minus 1. And then if I do 2 over 1, 3 over 1, 6 over 1, I'm not going to write them as fractions, because if I simplify them, I just get plus or minus 2, 3, and 6. And so the first part is easy. It's always just going to be the factors of 6. But then we need to account for 2. So I need to say plus or minus 1 over 2. And then 2 over 2. I'm going to list that on this first one, but really we don't need to list that one again, because 2 divided by 2 is just 1. And here we should say this is really just a 1. So we have that, but we don't need to list it again. It's redundant for us. And then we can do 3 over 2, which is important to list. And then 6 over 2. Well, 6 divided by 2 is 3, which we already have, so I didn't even list that. These are all of the possible rational zeros for this polynomial. So if there is a rational zero, which means the 0 is not irrational, meaning like square root of 2 or pi, or and it is also not a complex number, meaning like I or 5i or the square root of 6i. Then it is in this list of numbers. So you see, there was an infinite amount of numbers that we could have tried to plug in, and now we have limited it down to just 6. 1, 2, 3, 6, 1 half, and 3 halves. And we can test those using our remainder theorem to see if they work, and then do synthetic division to get that down to a quadratic, and then really easily, hopefully quickly, we're going to do quadratic formula. Okay? So that is it for this lesson. It was just one real quick concept and idea, the rational zeros theorem. And basically it's identifying P and Q and the factors of P and Q. So remember, P is that constant. Even though it comes before Q, it is the constant. It's going to be your last term if you put it in standard form. And Q is that leading coefficient. So it should be that first coefficient if you have it in standard form. All right, see you next time, guys.